No, we gotta get started. It's okay, don't mess with it. Oh, okay. I'll send it inside. I'll pass it on to you.
Okay, you're gonna get it started?
Yeah.
Wait, you know the slides look like?
No, I'm just gonna say one thing and then I'm gonna pass it to you and leave.
Just ask everyone to take a seat.
Hi guys, if everyone can take a seat now, we're gonna get started. I just wanted to introduce myself. I'm Roshni, president of AIS. Wanted to thank everyone for coming out today. You know, you guys have been working so hard on these projects, so this is your time to shine, present what you've been working on. I do have to leave right now, but I'll be watching from the live stream, so good luck everyone, and I'm passing it to Dylan now.
Okay, hey everyone, how's everyone doing? Let's start this event by giving ourselves a hand for making it to the end of AIM. Yeah, I just wanted to congratulate everyone here because you guys put in a lot of hard work, and it's nice to just a night for ourselves to show off all the hard work that we've been doing. All right, so let's get right into the slides. Our goal is to demystify AI. So we're a team of passionate individuals devoted to bridging the gap between people's awareness and the world of AI. And here are some of our core values that we want to embody. It's empowerment, networking, community, education, and connection. All right, so I wanted to take this time to let everyone meet the judges for tonight. So starting with Danny on the right here, each of the judges are going to introduce themselves to everyone. All right, you can stay there. Sure.
Hey everyone, I'm Danny Jacob. I'm the supervisor of data analytics at Sunoco LP. Basically, this past summer, Dylan was an intern there. I made sure he's got his sprint cards up to date, made sure he got his projects deployed, made sure he wasn't just slacking off. So yeah, the team was really excited to work with Dylan. He did a lot of great work. Was a great intern. Was a lot of really great projects on the for the team. It's still running today. I'm sure, right, Dylan?
Hi everyone, I'm Karina and thank you so much for having me. I also work under Danny, so he's my boss for Sunoco, and what I'm so passionate about and what I try to do every day at my job is answering how can we use machine learning to seize commercial opportunities in the energy space. So it's so exciting to be here and actually see, okay, I'm working on all these projects, but I love learning from younger people, so excited to see what you can teach me tonight.
Hello everyone, I am Ryan. I recognize a few faces here. I used to be in AIM. I went from mentee to mentor to director starting in fall of 2021, and I am about to graduate from UTD with my master's in statistics, and then I will work as a machine learning engineer for an energy company called IGS Energy, and I am very excited to see everyone's presentations tonight. Let's go! Well, okay, there we go. Hi, my name is Pratik. I was the vice president for AIS, I also founded AIM, so you're welcome. Currently, I was at a startup got bought, so that's fun. And before that, I worked at Amazon for 2 years in the AWS supply chain org.
Hey everyone, my name is Max Weinzerl. I'm a PhD student here at UT Dallas, and I actually started in my undergrad here in computer science, did my master's, and I'll be defending in the fall. I was actually here at the last Tech Tank. I was a judge for the Tech Tank, and yeah, it's just great to see everyone's projects come together.
All right, thank you, judges.
Yeah, so next, we can just hop right into project demos. So each group is going to demonstrate the work that they've been putting in throughout the entire semester. And we are going to start with our host group. So if everyone can give it up for our host group.
You don't have to. Computer projection. Here, try to present. Screen. Yep. And then the top you pick which Yep. That's right. Now you can do it.
Okay, yeah, sorry, it might take a while for these guys to connect to the computer.
So yeah. Cool. Perfect. All right, read. Oh my god. Oh, I think it makes you reopen everything. Shoot. Okay. Is this still sharing?
No, it went away.
What happened? Because I changed my permissions, it makes me reopen the browser.
Oh, did it?
His permissions weren't allowed for him to share his home screen, so to change the computer permission and then start Google Chrome. But we should be good now, right? Yeah, alright, sorry about that. Okay.
Oh wait, I don't see it on here yet.
Did you click present? Yeah.
There we go. Okay. This one. Yeah.
Hi all, we are AI enthusiasts and we're presenting to you EpiSense, an attempt at using AI to increase preparation through prediction for seizures and epilepsy.
Over 50 million people around the world are affected with seizure and epilepsy. Yet the power to predict this very life-altering condition remains inconsistent. And thus we have our project, EpiSense, an AI-driven prediction model through which we're able to better prepare patients, giving medical assistance in a very timely manner.
So our goal is to integrate wearable EEG devices with this model to help patients be alerted when seizure activity occurs. So EEGs are similar to MRIs, except they record the electrical activity of the brain, which are associated with seizures because they are the hyperactive synaptic firing activity. And using this EEG data, we aim to classify it into 3 categories: pre-ictal, which is before seizures; inter-ictal, which is in between seizures; and ictal, which is during seizures.
So the data that we used throughout this project was provided by the Neurology and Sleep Center in New Delhi. This data collected sampling neuromeasurements at a rate of 200 Hz for a duration of 5.12 seconds, providing upwards of 1,000 data points. This data was split into 3 parts of the ictal phase as mentioned earlier: pre-ictal, intra-ictal, and ictal. And through this data, we trained our model 80-20 split, giving us a better prediction for seizures.
So during this project, we experimented with a number of different models. While we won't be going into technical details for each model just yet, we will be discussing why we chose each model, as well as the feature extraction and pre-processing methods used. We also will be available for questions later. So to start with 1D CNN, we originally chose this model because it was supposed to be good for time series analysis, which thought we worked well for our data. However, the accuracy was not particularly great for this model. So we moved on to the SVM, KNN, Random Forest, and AutoBoost because all of these models performed well in a number of different research papers. And some of these are also used commonly in lab settings. Finally, we settled on a fusion model because we already had all these models in place. And the fusion model allows for the weaknesses of an individual model to be made up for by the combination of all of them.
Alright, so here we have certain features and pre-processing techniques that we've used across all 5 models. They include minimum, maximum, mean, standard deviation, skewness, and kurtosis.
So for SVM, it uses all of the features in the L section alongside root mean square, principal component analysis to reduce dimensionality of the data, and standard scaling to normalize the data to improve accuracy.
For the KNN, or the K-nearest neighbors, it uses a combination of sinusoidal and time-domain features to provide better clustering information.
And for the random forest and AutoBoost model, we chose to use a technique called discrete wavelet transform, which is similar to the Fourier transform, except it's specialized for time frequency localization.
And for the 1D CNN, the model architecture involves the use of batch normalization and max pooling, using which we extract the essential features from the data. And we also included an AdBoost optimizer to increase performance of the model, and also incorporated dropout layers in order to prevent overfitting. Alright, so here we have what we call as a fusion model, which is an ensemble method of probability averaging. And so each of the 5 different models gives us a prediction. So either it can be ICTAL, inter-ICTAL, or pre-ICTAL. Now each of these predictions can be broken down into 3 prediction classes. Prediction probability for the ICTAL, for the inter-ICTAL, and for the pre-ICTAL. And then once we have the prediction probability for each of the 3 classes across all the 5 different models, we can average them out and choose the highest one from them. So for instance, if you see in this pie chart over here, the fusion prediction shows pre-ICTAL, because pre-ICTAL is the highest amongst the 3 classes at 54%, and we do this for every sample in our data, and that's how we arrive at a predicted value. So here we have a demo app, and if you can see over there, we have samples from 0 to 29, so basically 30 samples. And here we also you can also see the graph of the EEG sample. And for instance, this is the sample number 18. And now over here, if you see, the fusion prediction is pre-ICTAL, and the correct label is also pre-ICTAL. So in this case, our model is correctly able to predict what the value is based upon a test data, with a fusion accuracy of about 93.33%.
So some areas we'd like to improve on for the future would be further cleaning up this data set, further parameter adjustment for each of the models, using different types of EEG data that may have different sampling rates for each model to hopefully improve accuracy, as well as obtaining a more consistent and larger source of medical data to hopefully get better training results.
So thank you guys for listening, and we would love to get connected with all of you. And a huge shout out to our mentor Rahul and Parisa, who couldn't be here with us today.
Alright, thank you, EpiSense. Next up, we have Drainage Group. So having to give them a round of applause.
Yeah. Either your entire screen or you have a specific window you want to. Are you going to show a demo after this? Wait, is this all of
Okay,
it?
all of the mentors, make sure you guys join the StreamYard. And then once it's your guys' turn to present, then you guys just share your screen. But make sure you are already inside the StreamYard.
Okay. There's a mic right. Did you? Oh, yeah.
sugar sense. And my name is Ishita Shah. I'm Shreya Krishnan.
I'm Nirmal Fideli. I'm Rohan Suri.
Okay, so a little bit of background. So, over 550 million people worldwide have diabetes, and people with diabetes are at a higher risk for health problems like heart attacks, strokes, kidney failure, and more. And a study by the National Library of Medicine found that over 25% of patients were misdiagnosed by diabetes. And a misdiagnosis of both diabetes and not having diabetes can have detrimental effects on a person's health. So it's like of the main purpose of our project. Okay, so a little bit about our data set significance and epidemiology. So the causes for type 1 diabetes is family history and age, and causes for type 2 diabetes is weight, age, family history, and physical inactiveness. So the populations most at risk are Asians and Africans, and so India is home to 77 million diabetics, which is the second highest prevalence in the world, which has incorporated some variability into our data set for the model to be more versatile, trained, like differentiating between true positives and negatives. And lastly, more about the data set. The patients were females who were 21 years and older, and they are primarily Indian descent. So lastly, what did our process and timeline look like? The first step was data analysis, where we analyzed and got more context about our data set. Then we did data cleaning, where we made the data more accurate by filtering out the discrepancies. Then came the data visualization, where we created statistical graphics like pie and bar charts, and we analyzed the trends. And then we did model training, where we trained the data set using many modeling techniques. And then lastly, we did model selection, so we selected the best performing model. And then actually lastly, we did the front-end integration, where we created the front end and then integrated that to the back end to create the final product.
Our goal is pretty straightforward: to create a reliable solution for diabetes prediction using machine learning. We gather key health metrics such as glucose levels, BMI, and age through a user-friendly front end. The algorithm analyzes the data and provides a positive or negative result, helping individuals quickly gauge their diabetes risk. Our solution bridges technology and health to empower users, quickly giving them insight into their well-being. This not only supports early detection, but also encourages positive health management. Let's talk about how SugarSense works. It starts with data collection. Users input their health metrics through an intuitive interface. We then pre-process this data for our random forest model, which we chose for its impressive accuracy. What's great about SugarSense is its immediate feedback, which enables users to act promptly if necessary. Additionally, by consistently refining our solution with new patient data and user feedback, we ensure that it stays relevant and effective. It's like having a personal advisor that's always getting smarter.
Now onto the technicalities of our model. So we started with pre-processing. So to clean our data using data cleaning, we took out the nulls as well as the zero values in our data set. Luckily, our data set actually didn't have any null values. So we did it just to ensure that our data was clean, but it wasn't necessary. We also did data visualization so we could analyze the key features that we wanted to use in our model. And so we first looked at the output label, which was whether the patient was diabetic or not, to see what was the distribution of true versus false. And then we also created different graphs. This is a heat map that shows the correlation between each of the features that we have. We also created pair plots as well as different scatter plots, and found that none of the features had significant correlation, which was good so that our model wouldn't have much bias. Now on to selection and training. For our training, we did an 80-20 split, where 20% was used for testing. And we used multiple different models, including SVMs, naive Bayes, as well as random forest. And as mentioned before, although all of the accuracies were pretty similar, random forest was the highest with about 80.5% accuracy. So we ended up using the random forest model. And here's the confusion matrix for the positives as well as false positives and false negatives. And our statistics. Now on to our demo.
So this is an example of someone who has low diabetes risk. And then this is an example of someone who eats fast food and has a high familial diabetes risk.
So we successfully developed a ML app using a random forest model because of its accuracy of 0.81. We chose this model after evaluating 6 different machine learning models, and we also used grid search CV to hypertune the parameters and maximize the accuracy. Moving on, in the future, we would like to implement a hybrid model to improve the diagnostic capabilities. We also like to use ADA boost to enhance performance by reducing the false positives and increasing the detection of true positives. One case where our model back was detecting type 1 and type 2 diabetes. So by implementing hybrid models, we could increase its utility and the accuracy of its diagnostics. So thank you for listening. We're looking forward to hearing the rest of the presentations about different AI applications and its models, and we're open to any questions you might have.
All right, thank you, Sugar Sense. Next up, we got Orlando's group, and their topic is called Science Speak. So if everyone could give it up for Orlando.
Please try to present. Okay, go for it. Ashwin, try it again.
People that are finished every time because
Someone go already. Do you remember?
Sugar Sense was still there. I think they're gone now. Even if they moved to, actually, maybe don't move to. I mean, you could because there's only one have to.
Yeah, yeah. Yeah, we needed space. Here, is it? Are you really rejoining? Yeah. Should I just kick people that have? I think everyone who already left.
Because there's like more than 10.
1, 2, 3, 4, 5, 6. No, it's dead now. We're good.
You just tell them to join.
Okay.
Hi, our project is ScienceSpeak. ScienceSpeak is an ASL learning model helping those learning ASL for the first time practice their signage. This is our team. I'm Manish, this is Shremoy, that's Sahil, that's Samir, and our mentor was Orlando. So just some context before we show you all the model. There's about 500,000 people who use ASL in the United States. However, only 2.8% of that population knows American Sign Language. Therefore, there's a clear communication barrier for those learning ASL.
So the solution was creating a real-time ASL learning tool. Our model supports letter recognition and also includes a live feed from a camera with real-time hand tracking, visualization, and feedback.
And we're gonna show a quick demo. So here, as you can see, it's gonna like read from.
Yeah, so here, as you can see, Sahil is signing A, now he's signing F. And one thing I want you all to pay attention to is really these red dots, right, that are on like the different parts of this hand. That's going to be a key part when I explain how the model works. But yeah. So the model works by using 2 different pieces of technology. First is a Google library called MediaPipe, and second is a random forest classifier. So MediaPipe is a library that
basically enables the application to detect hands, and that's what plots those little dots called landmarks right on those hands. And so the way it works is we use MediaPipe to then detect those landmarks, and then for each image, or for each input for that matter, we then for each landmark, take the X, Y, and Z coordinate and put that in a list, right? So that's your input, and then your output, of course, is the detected value, i.e. the letters A, B, C. Then what we do is we take that data set, right? So each instant being that list of coordinates, and then the output being the letters, and we input that into the random forest classifier, which creates a series of different trees and clusters them together to ultimately predict, is this A, is this B, is this C? The reason why we don't just go ahead and take a larger tree that takes the entire data set is because that would overtrain the model on the training, or that would overfit the model on the training data, right? Which means it isn't really good for variability. So if we then kind of give it an input that it's not trained on, it might predict it wrong. So having a random forest classifier makes it more keen to variability and prevents overfitting on the training data. But yeah, and now we can talk.
So for the learning tool ScienceSpeed, we decided to go with React JavaScript for our front end. And we also created a camera feed so you can see what you're signing, and also shows the predicted output of the gesture that you're signing. And to do this, we also use Python Flask to integrate our backend with our front end. And we use Flask to basically take our model and have it compute the video feed and display it onto the React.js front end.
So some things we're going to implement in the future are increasing our dataset size for better model accuracy, dynamic translation, which means we can support things, detection of verbs, things that require more motion than just static letters, and then implement more web app features for things like an interactive tutor, which should be potentially monetized in the future. Thank you.
All right, thank you, ScienceSpeed. Next group we have is Tucker and Vader's group, and their project is called Analyze AI.
Yeah. It should be near the bottom, I think. Yeah, that's fine. You want me to click present? Yeah, cool. Perfect. That works for me. You all good? All right, thank you.
All right. Good evening, everyone. We are Analyze AI. I'm Andy.
I'm Emma.
I'm Anu.
I'm Telego.
And these are our two wonderful mentors, Tucker and Veda. So let's get right to the problem, shall we? So whether you're a student, teacher, alumni, or anyone who's ever taken any class at any university, I think we can all agree on one thing, right? Professors suck at explaining things, right? Although their academic papers or research could be revolutionary, a lot of the time their labyrinthine lexicon and complex field-specific vocabulary poses somewhat of a language barrier to anyone outside of the professionals in those respective fields. So the idea for our project comes from trying to tackle the question of how can we simplify these concepts into ideas that are easier for everyone to understand.
So the application we built allows its users to gain a better understanding of the articles they're reading through explaining the advanced vocabulary and sentences in a simpler manner. This will make the article more comprehensible to the reader while allowing the reader to understand the article not regardless of their level of understanding of the subject.
Today I'm very excited to share the technology stack we use in our project, which is an innovative chat PDF application. So we made use of various technologies like React for the front end, which is used to manage, which is used to build the user interface. It also made it very easy for us to manage the navigation components of our chat area, ensuring a very smooth experience. On the backend, we use Node.js, which was used to handle multiple user queries simultaneously. And for the technology aspects, we integrated the OpenAI technology, which enabled our chatbot not to only respond diligently to user queries, but also learn from our interactions over time to provide more accurate responses. And together, we make use of all these technologies to build our projects.
So this is our homepage where we can see all the PDFs that are currently already uploaded. To upload a new PDF, we just click on the button, which is, so now we can see the upload page. So we can pick the PDF that we want to upload, and once we see the success message, we can go back to our homepage and click on the PDF we just uploaded.
Once we click on the PDF that's uploading, we open up the application page, which has a PDF rendered and a text layer separated. When you select the text layer, it pushes that text into the chat box, which you can then directly press send without having to really copy and paste. You then receive a message, which is generated by ChatGPT, which you can then also download from the download chat history button. That way we can save both the conversation, and if you want to download the original PDF, there is also a download PDF button.
So this is our sign up page where we can create an account, and all we have to enter is the name, phone, email, username, and password. So we can go into our about page, which has a little bit of information about all of the team and a bigger pickup we have. So in conclusion, our project features the upload page, the home page, application page, and the chat component. And each part is important to support our core goal, which is to create an interactive AI chat platform where users can upload their questions and engage directly with the chat. Thank you.
All right, thank you, Analyze AI. The next group up that we have is Ryan's group, and their project is called Cinefusion.
I'll be out of the way in a second. And then could you open the? Okay. Yeah. Is that? Click on it quick. Grab. Perfect. Oh, yeah.
Alright, so are you a low-budget indie movie producer who feels as though all your time and money is just being sunk into nothing but your movie CGI and special effects? Or perhaps are you a VFX artist who feels overworked because of the amount of editing and CGI that your movie producer is giving you? Well, my name's Corey, that's Noel, that's Hari, that's Abiram, and this is our mentor Ryan, and we present to you Cinefusion. So Cinefusion is an AI tool which generates movie special effects in real time. So, so let's say you wanted to film a high noon Wild West shootout scene, but the only props you had available to you were Nerf guns. So with Cinefusion, you could turn these Nerf guns into AI-generated real guns all in real time while you're shooting the shootout scene. So with that being said, I'll pass it over to Hari, who will get us started on how exactly Cinefusion works.
Right, thank you. So today I'll be going over the three major components that make Cinefusion work. These are YOLO VA, MobileSim, and Stream Diffusion. Now I'll go more into detail about YOLO VA. So YOLO VA is essentially an object detection algorithm which checks and classifies any objects in the image. And how does YOLO VA do this? It's pretty simple. Just gets the bounding boxes, as you can see, that's speed, and that's the time. It gets the bounding boxes of each object in the video, it picks what to change based on the prompt, it sends it to the MobileSim to do the rest of the work. To put this in perspective, let's say you were trying to film a movie set in the 1950s, but you only had modern cars. Cinefusion could turn those modern cars into retro cars to fit for your movie. I'll pass it to Agro.
So a crucial step in our pipeline is MobileSim. MobileSim is a segment anything model that masks images in a scene. It masks objects and components of the scene. So what it does is we receive a frame and the bounding box from YOLO, and then mask the object with the tightly bound mask that surrounds it. This is game changing, especially for directors, because they can select specific props or structures within a scene and then mask those objects to be replaced with Stream Diffusion. So that brings us to Stream Diffusion. And what is it? To sum it up, it's an image generation model. And it takes in a frame and it can generate an image depending on what you want. So in our pipeline, we receive the mask from MobileSim and then generate an image depending on what we want to change it to. And because it does a stream of images, it creates a video. So in our example, instead of spending thousands of dollars to buy vintage cars or to rig and composite a computer-generated car model, you can instead just use Cinefusion and simply replace the car.
So we've talked about it a lot, but how about we show you what exactly it looks like by turning myself into Batman. So it'll take a few seconds to load.
Close the terminal. Okay. And then, yeah, make a new terminal. Got it. Okay. Yep.
Sorry about that, technical difficulties.
Shoot. Sorry, close it one more time. Control C. Yeah, that must close it down. Yeah. So how do we do it? Server first.
Okay. So how it works is once we give it a prompt, our basic prompt is Batman, that's the default, but we can change it. It will.
Give me a second.
So how it's supposed to work is it'll create a webcam socket that will show you exactly me with the YOLO V8 on there with the bounding boxes around it. And then it will also show you the final image, which is supposed to be me, but as Batman. And it works better with a better contrast, so that's why I took off my coat. So with something more light, it'll work better with that compared to something darker.
It's because we're connected to it's streaming to the.
So yeah, it's currently not working because we are streaming to the actual StreamYard, but how that is exactly how it's supposed to work. Thank you.
Alright, thank you, Cinefusion. So after everyone presents one by one, we'll come back to Cinefusion and have them just connect to the computer and present your demo. All right, let's give one more hand for Synafusion. All right, next we have Shruti Stew, which is called Zone Defend.
Yeah. They haven't not yet. Can we put this? Or, it doesn't matter where. You just have to click present. Okay. This is fine.
Okay, and StreamYard has a max capacity of 10.
That's good.
So if you're already in the StreamYard, you might get kicked. And then you just have to rejoin. Okay, and Zone Defend, their team has asked us to do a drum roll at the beginning of the presentation. So if everyone could do a drum roll real quick.
Hi, my name is Anthika. I'm Laksha.
I'm Love.
I'm Zubia.
I'm Daniel, and this is our mentor, Shruti.
And we're here to present Zone Defend. Every year, approximately 15% of students face unintentional injuries caused by anomalies.
Like Love here.
In a world teeming with threats, the number of anomalies is rapidly increasing. From stealing and vandalism of student property to shootings and car accidents in school parking lots, current measures in place fall short in detecting and deterring these evolving threats, causing harm not only to students, but the greater community. That is until Zone Defend. Zone Defend is an AI model used to detect common anomalies on college campuses through the use of real-time surveillance footage. Our product is designed for medium to high population schools, which is over 5,000 universities here in the United States and their security department. Now on to Love to see how it all works.
At the core of our tech stack is Python. Speaking of core, she got me good right at the core. OpenCV was used for pre-processing the data for our model. Matplotlib was used for visualizing the training and testing data for our model. And RunPod was a crucial component for training our model as it provided the graphical computational power to process our lengthy data. Finally, PyTorch was used to power our model, which is
i3D, which is based on successful ImageNet architectures. We take videos as input and split them into RGB frames to capture spatial features and optical flow frames to capture temporal features. And for example, what they look like, here you can see RGB is in color and tries to capture the spatial atmosphere, whereas optical flow captures the horizontal movement across time.
Our overall data set consists of videos from the categories of assault, arson, road accidents, shooting, stealing, vandalism, fighting, and normal.
So let's see how our model holds up. When we tested our model, when we graph the true positive versus false negative rate, rates, a good score for complex tasks is this, is around 70 to 80% is considered good. And our model on average has a score of 78%. And then shown on the legend are the scores for other categories.
Now, Daniel's going to be doing a live demo of our arson data set. This is the video that he's going to be using.
All right, so let's run our model. And while we let our model run, I'm going to give it back to Zubia to talk about the other results.
First, we have a video categorized as normal. As you can see, there are no anomalous events going on in the video, other than us being academic weapons. Once we look at the results, you can see that the highest percentage is for normal, almost 90.7%. Next, we have a video categorized as assault. Just a disclaimer, no Daniels or her in the making of this video. Looking at the results, we can see that the highest percentage is for assault, almost 52.9%. Next, we have a video categorized as fighting. And looking at the results, you can see that the highest percentage is for fighting. Now I'm going to hand it back to Daniel to talk about our live demo results.
All right, so it took 39.4 seconds to run, must be because I'm streaming. And our highest category is arson at 94%, followed by vandalism at 5%. Very nice. Now, onto Laksa for future plans.
So in the future, we would hope to make Zone Defend a more accurate model and also use shorter frames of motion to do so. We would also like to adapt Zone Defend into our daily lives and partner with college campuses to incorporate Zone Defend into their safety measures as well. To know, Zone Defend's primary target audience is educational institutions, but it can be applied in other public settings as well. For example, in workplaces and traffic camera systems. So how it would work in a traffic camera system is that if there's any anomalous activities, in this case it would be road accidents, which is one of our categories that we run against. The traffic camera will be able to catch that anomaly and say call 911 immediately with the location of that event. So in conclusion, Zone Defend helps in automating anomaly detection by boosting efficiency and helping to uncover more irregularities.
That's Zone Defend, where innovation meets security. Thank you.
All right, thank you, Zone Defend. Next up, we have Angela's group with Amplify. Do you need the microphone for your computer? Wait, sorry?
I think ideally we want the microphone from my computer.
Okay. Do you need the speaker from here?
Probably not.
Okay. Then we should present.
Is there feedback?
Sure, yeah.
Should I go close though?
I don't think it makes a difference. Should be fine.
Okay.
This. Wait, that's not my thing. Sorry, I can't see. Is it? I can't see. Oh, on the left. There we go.
Hello, everyone. My name is Oscar.
My name is Shun.
And my name is Jacob. And we're representing Amplify, which is a software that is used for gamers to play games using their microphone. Right now, gamers primarily use 3 devices to play games, and that is the keyboard, the mouse, and the controller. But these devices do have their drawbacks. For example, in the keyboard, as some of you might know, you can fat finger and then hit unintentional keys that you did not mean to press. And sometimes it can be pretty unnatural to do some things with the keyboard. The mouse also is very precise and you have to be very good at it to use it. And the controller is pretty hardware dependent and is expensive. And gamers also do not use their microphones to play games, which come with pretty much every modern gaming console. So, this is where we introduce Amplify. We amplify sound to immerse and play unbound. Say goodbye to your keyboard and your mouse, and say hello to playing with your mic.
So our idea for Amplify is to have a preset list of sounds that we make, and when we make the sound, Microsoft Cat Model will detect it. The user will have the flexibility to choose any sound, which could be a clap or a whistle or anything else. Furthermore, they can define complex macros, and once Amplify hears the sound, it immediately activates the corresponding macros. So how it works. It is pretty simple, and the process starts off with our audio stream. Our program will continuously capture audio from our microphone, and once the audio is captured, it is sent to our audio classifier clap model. The result we get from the clap model will activate the corresponding macro, which simulates a queue passes in game.
So for the CLAP model, it takes two inputs, the label and the audio. Both of these inputs pass through a pre-trained audio encoder and a text encoder. These encoders output a embedding for each of the respective item. And then with those two embeddings, we compare them, we do a cosine similarity comparison, and we will get a result of a dictionary of each label and their respective scores. For our purpose, we're looking for the highest percentage. The highest percentage would be what CLAP predicted, what label was, or what sound was said. So let's go to a demo. So I'll first start our model. And we'll be using Mountain Blade 2 Bannerlords.
It's gonna be a bit laggy.
Sorry, the game is loading.
Actually, including the actual on my adapter.
Alright. We begin by going to this village that we're gonna raid. Begin also action, raid village. So the first audio cue we're gonna do is for a formation, a circle formation for our soldiers. And that's gonna be done with a clap. As you can see at the bottom left, it says the arches are circle, so they're all going down to start formation. The next thing we're gonna do is a charge. So now at the bottom left, you can read that the archers are charging.
Oh.
So that's the end of our presentation. Here's a GitHub to our project, and we want to say this is an honor for our friend Jochen that couldn't make it today.
All right, thank you, Amplify. Next up, we have Josiah's group. It's called Foursquare.
Yeah, are you on the, yeah, just click present. Share screen. Yeah, share screen again. Is everything on this window? Or are
Yeah,
you
just-
going between multiple windows?
just
Or
this
is it okay, perfect.
We're presenting the demo on a different.
Then you should just go back to the thing then, instead of streaming, because you're only streaming this tab. So go right here. Yeah, just stop it. And then share screen. This time, see.
Tell me screen.
There. Alright, all you.
Hello everyone, we are Foursquare and our project explores how DQ networks can be implemented with two-player games, and for testing we use Connect4. So this is our team. We have our lead developer Anubhav, we have our front-end developers me and Ankit, and we have our AI specialist Ishan, and we have our mentor Desai. So for our project timeline, our very first step was to implement a playable instance of Connect4, and we did this by using NumPy. And after this, we created a Minimax agent, and we also optimized our Minimax agent by implementing alpha beta pruning. And then we created our Q agent, and so to do this, we developed a Q network, and then we trained it against our Minimax agent. And then we also explored alternative architectures by implementing a CNN, a convolutional neural network.
Alright, so the training results for our Q network were quite mixed. Against a random agent, it was able to easily beat it 95% of the time. After analyzing the game, so it was clear it was just repeatedly putting chips in a single column and just relying on getting a vertical stack to win. Versus a low-depth Minimax agent, the Q agent struggled at first, and that's because there is simply a huge number of states. Putting one chip in a different column can change the entire course of the game. But in the end, we did get our Q agent to consistently beat a deterministic Minimax as player one by memorizing a solution. Training against itself was futile because, again, it just knows to memorize solutions. So it didn't learn to generalize strategies and played quite poorly against itself.
So next up are some potential improvements. The first one is the CNN. By adding a CNN of kernel size 4, the model was much better able to recognize certain patterns, such as preventing the Minimax agent from getting to direct victories or creating double threats. The next improvement that we can make is probably using a different algorithm. For this one, we used DQ networks, and they are known for their relatively poor performances when used in two-player games such as ours. Even though we were able to push our model to win against the Minimax agent at least once and have a 95% accuracy against a random agent, some more training time and some coding improvements can definitely help the model do better.
So next time I'll be talking about the front end. And for the front end, our framework of choice was Radio. And we use Radio over something like React.js or any of the other high-end frameworks because it provides a way to implement a simple input-output-based interface without having to learn HTML, JavaScript, CSS, or any of the advanced languages. Instead, you can just use simple Python to make an interface. We divided the front end design into two portions, image generation and event handling. For image generation, we primarily use the Python imaging library to programmatically generate the board image using different colored red and yellow tiles representing each pair of chips on the board. And for event handling, we use a row of 7 buttons laid next to each other right below the game board, as you can see in the image right here. And upon clicking each button, it makes a move in the corresponding column and then updates the board accordingly.
Alright then, we will be doing a quick demonstration of a game. So here I have a game already loaded up. I'll push start game to get it started, and the entire board loads it. Let's play in the center, okay? And let's make a couple of moves and see how this agent plays. So we can see it really likes this vertical stacking strategy. Unfortunately, I'm not gonna let it win outright, which is sad. Let's keep playing a bit. As you can see, it's starting to realize placing more chips close to each other is a good idea. And let's see what happens if I give it the opportunity to win. It takes it, which is quite good. Okay. Admittedly, our model still uses simple strategies, but we are planning on improving our model, working on it more in the future, and we plan to get this Q network to be successful. We want to play a game against a high-depth Minimax and actually win, not just memorize the solution. Alright, if anyone has questions, we'll be taking them.
Alright, thank you, Foursquare. So right now in the schedule, we I hope that we have a 10-minute break, but we're gonna go ahead and skip that because we started late. So next we have Amar's group, and there's what is called Chat UTD. So let's give it up for Amar's group.
Are you showing anything on something separate from the slides?
We
No, it's just slides.
We can do an introduction.
Alright. Well, good evening, everyone. We're here to present our project that's called ChatGPT AI Advisor. We're going to quickly introduce you to our team. We have Amar, who was our mentor. We have Amer, who worked on the database. Daniel, who worked on an AI project. And then Trevor and I, Leon, worked on the front end. And we're really excited to show you this project tonight. And as of right now, there's no other product in the market that combines the in-place counselor and virtual assistants in this manner. And Trevor here to tell us more about the purpose of this project.
So, there are a lot of students here and few advisors, right? So this causes a high workload for these advisors and long wait times for students. And that is what our project aims to fix or help. And in doing so, it allows advisors to do other things in their time, such as approve graduation requests and send important info to deans. And it also aids students by having instant feedback and faster wait times. And it aids advisors by having, they'll have lower workloads. And then Amar is going to talk about our project architecture.
Thank you, Trevor. So when it comes to the implementation of our project, so for the front end, we have React. We get a user message. We send it to through Flask API to the backend, and so our RAG model gets the message as well as the data from the SQL database and the coordinate database, and it uses all the information to send the response back to the user. And we're gonna have a quick demo to show that. So we have technical difficulties. It's supposed to play a video, but essentially we send a message to the chatbot asking it what CS classes we can take as a freshman. It gives you a couple of recommendations, and the next question we ask it what freshmen and what schedule works best for like the freshman classes, and it gives you a couple of recommendations of teachers and schedule, and as well as their rating. Here I'm going to get into Amir, who will talk about some technical challenges that we had.
So one of the technical challenges that we had was effectively querying our SQL database. Now we implemented a hash method to minimize hallucinations between the vectors. So now we can process each vector that we're wanting to query more efficiently. Another problem that we ran into was the data available is not optimized for what we really want. So we went through a couple of iterations, and now we're slowly working on like hashing out that data, getting it nice for our purpose. Another technical challenge that we had was funding. We were using free versions, and there's lots of classes here at UTD. There's lots of data that we need to go through that we want available. Another thing is the AI was hallucinating the prerequisites for a while, and Daniel's going to expand a little bit more on that.
So the first step is obviously to extend the database
And the next step, we're trying to implement function calling within OpenAI to maintain better data accuracy. We also try to implement Calendly to connect students to advisors within our chatbot. So if the advisors are free, then we can get the students to connect to the advisors. If they're busy, then I guess not. Now, we have a wide vision for this project, and we are willing to work on this in the future, because we're not doing this for the club. Well, we're doing it for the club, but it's more than that, right? Because we're trying to help people, we're trying to help students and advisors at the same time, reduce the workload for advisors. And before this, I was talking to my friend Amir over here, and I was telling him about the potential, and we are all passionate people. Show me how excited you are.
I'm really excited.
Yeah, anyway, with your support and our commitment, we will make UTD a better place. Thank you for listening.
Alright, let's go. Thank you. Y'all take care.
Alright, thank you, Chat UTD. Next up, we have Thomas's group called Deep Detect.
We're gonna present on this. This one, right? Yeah. Wait, is this you?
Deep Detect, not Deep Text. Did you click present? Share screen. Share screen. I just did the entire screen. There you go. All right. All you.
Hello, everyone. We're Deep Detect, and my name's Jonathan.
I'm Shafiq.
I'm Neil.
I'm Rashid.
I'm Gina.
I'm sorry.
So in case you're unaware, a deepfake is when you take one person's likeness and you put it on another person. An example of this is face swapping. And it's used by using deep learning models, such as generative adversarial networks, or GANs.
Deepfakes are often made to support fraudulent activities or to create misinformation campaigns. For example, in February, there was a recent police case where a deepfaked video call of a CFO was used to make employees transfer over 25 million to fraudulent bank accounts. Cases like these are why it's essential for companies to care about deepfake detection.
So let's talk about how Deep Detect works. Here we have a little demo here. So users choose an input type, so an image and or video in any combination, and then they input a possible deepfake and a real reference image of the subject that they want to test against. Here we input images of 2 images of Brad Pitt. You'll see them on the next slide. And in our output, in a moment, we'll receive the Euclidean distance between these 2 images, which I'll explain in a second, and our prediction, which in this case is not deepfake. So to go into more depth, the user inputs the 2 images or videos, and so if it's a video, we take a sample of sequential frames, and then we can treat them the same as an image. And so these frames are then run through our pre-processing, which is using the FaceSet model to crop the images to get a better capture the face of the image a little bit better. And then we run them through the model, Inception ResNet. From Inception ResNet, we get an embedding. And so embeddings are mathematical representations of the images. And then we can use these embeddings to compare them. And the metric that we use to compare these embeddings is Euclidean distance. If the Euclidean distance is closer or lower, then there's a much higher likelihood that the 2 images are both real of the same subject. And obviously, if it's further away,
there's a lower likelihood. So we set a threshold, and then if it's below that, we determine that it's not a deepfake. And if it's higher than that, we say it is a deepfake.
And in case you'd like to catch what images and videos we used in our demo, the bottom images are real images, and the top images are the tested, suspected deepfake images.
Our Inception ResNet V1 model was trained on the VGG Phase 2 dataset, which has 3.3 million images of 9,131 subjects. We tested the model on Celeb Deepfake version 2, which is a dataset with 590 real videos of 14 celebrities and 5,639 deepfaked videos of the same celebrities, which were created using 10 different generative AI models. We chose CelebDF V2 as our test dataset because the deepfakes are high quality and are hard to distinguish from the real videos. On the bottom is a graphic from a 2020 paper by the authors of the CelebDF dataset, where they compared it to 6 other datasets with real and deepfaked images and videos. And what they found was that the CelebDF dataset, of the 9 deepfake detection methods they tested, CelebDF deepfakes were less likely to be detected as deepfakes.
So to analyze the performance of our model, we plotted a ROC curve, and we see that the dotted blue line basically means it's random chance of flipping a coin. So the area under the line is 0.5, and our curve, which is the orange curve, has an area under the curve of 0.69. So we're really proud of our results, and basically how we plot this curve is we have the false positive rate on the x-axis, which say if the model detects a deepfake when it really isn't, and then the true positive rate on the y-axis. So the goal is to get the value as close to 1, and we achieved a value of 0.69. And the state-of-the-art face-only models is about 0.8. So we're proud of our results, and the way we can enhance and get better results is by using a transformer model, because you have to use more training data, and it's more computationally expensive. But with that, it will yield better results. So that's how we will improve our model going forward.
Thank you so much.
All right, thank you, Deep Detect. Next up, we have Michael's group with Deep Clean. Also, hang in there, guys, because food should be coming soon. Also, at the end of the aim night, we'll be giving you guys your guys' AIM shirts. We did not forget about those.
Yeah.
Good afternoon, guys. Thank you so much for giving us the opportunity to present our project today, Deep Clean. All right, I'm going to be, my name is Sanlai Guru. I focus mainly on front-end development.
My name is Nicholas, and I focus on the shallow UW net development.
My name is Mihir Sharmalasedi, and I worked on the CGAN development.
My name is Deepansh Kesavani, and I worked on unit development.
So the problem with many underwater images, our data set in question, is that when images are taken underwater, they have a tendency to have visual and color distortion. This is due to light refraction and sediments in the environment playing a larger part than they should. This is a raw image here. The way we solve this is by implementing color correction and object removal to have a much better true to nature image.
Technologies used were mainly PyTorch, Meta's machine learning library with extensive deep learning tools. Gradio, a Python-based framework for building and deploying machine learning models, and Python, the language where all this beautiful logic is written.
The data set we use is a UIEB data set. This it consists of 950 real underwater images and 850 reference images for us to test on. Up top are the raw images that we're testing, and the reference images, we're using that to compare from the outputs we got from our models. We did 20% of our, we set 20% of our data set for test pairs. To increase the amount of variety of data, we had to train and perform data augmentation. The three kinds we did were random erasing, Gaussian blurring, and random rescaling. Up top, you'll see what it looks like.
Next, let's talk about loss functions. First one, we have MSE loss, which essentially creates a criterion that calculates the mean squared error between our model's predictions and ground truth, which in our case would be the reference images.
The second loss function is VGG loss. VGG loss enhances image denoising by focusing on perceptual quality rather than pixel accuracy. It uses a pre-trained VGG network, and this approach aligns denoising with actual human visual perception and allows for very aesthetically pleasing results.
Okay, last but not least, we have the L1 loss function, which basically takes the generated image versus the actual image and just computes the absolute difference between those two. And now, going on for our models. Our problem solves our approach with two models, the first one being the shallow UWNet, this is what I built. It is basically a model that balances the trade-off between image quality and limited resources and computational tasks. The architecture is explained in a visual manner here, and it focuses on 4 main points. The first point is a single convolution that basically will help us extract more features as the image goes by. Then the activation function, which is a rectified linear unit. And then it goes through 3 convolutional blocks, which basically just deal with pixel-specific values and extraction of colors. But we also have the concatenation at the skip, because after every single process is made on the convolutional block, our image is stretched or facing to the sides. And we gotta work on it to regain the actual value, and then it outputs the noise image at the end.
Our next model is the CGAN, essentially split into 2 parts, the generator and the discriminator. So the generator's job is to generate fake images, and the discriminator's job is to determine whether the image is fake or not by comparing it with our real reference images. For a closer look on the discriminator, it essentially uses a basic convolutional classification architecture. And for our generator, we actually use the UNet, which is split into 2 parts, the encoder and the decoder. The encoder's job is to downsample the image, making it smaller, and the decoder's job is to upsample the image. The main point here is that at the end of the day, the generator gets better at generating images, and the discriminator gets better at determining whether the images are fake or not.
Alright, here are the performance metrics. As you can see, the CGAN is much better in most properties, except for inference speed, where shallow UWNet has a clear lead. Alright, we're going to have a quick demo here. So Michael Mentor is inputting a raw image using, as you can see, the radio button choice is shallow UWNet, so this is the shallow UWNet model looks like. And you can see that the CGAN is much better in color correction, even though sometimes it can tend to over-exaggerate, and while the UWNet underemphasizes it. Here you have a CGAN running an image, underwater image. You can see how clearly it's able to grasp the coral reef's natural image here. Naturally, with the green, you can't really see these images for what they are. Well, thank you guys so much for listening to us. We appreciate you.
All right, thank you to Deep Clean. Next up, we have Eamon's group called Catch Fake.
Did we already do the demo?
Yep.
Why did you? Just click the link to join the stream. Oh, okay. I didn't click the link.
Yeah.
And make sure the rest of you guys join the StreamYard. And if you get kicked out, just join it back.
Yeah. I mean, you're not going to use your webcam.
Oh, should I use this?
It doesn't matter. We're not going to be playing it on the. Then present.
Yeah, we do.
Do you want to play the audio?
Yeah.
Let's see, that's probably going to cause feedback, isn't it? Maybe you're probably going to have to mute this mic then.
Okay, so we should be able to get the mic in the store.
Yeah, whenever you play the video.
Okay, yes. Increase the volume.
I would say so, yeah.
Okay. Increase the volume. Okay.
Should be, yeah. Mute this until you play your video, so that you can use the mic to talk. And then when you play the video, you turn off the mic and then
the video is back on.
Yeah.
So we can play the video and then we don't have the mic on stream.
Yeah. So click present here.
Turn it off because the mic. Don't. Share screen. Okay. Awesome.
Is it playing? Yeah.
Okay. Present. It's not putting in the audio. It's not.
Here.
Yeah. Did we download it or something?
No, it should be.
Can you just?
Oh, wait, this does not need to be plugged in at all.
Oh, okay.
Okay. Yeah, I wonder where the feedback's coming from. Also, why is the audio?
We have audio to share or something.
Yeah, that's a good question. Oh, I should mute on this thing. That's what I should do. It's not yet, but it can be. Right, thank you.
Okay, so ladies and gentlemen, sorry for the audio problems. This is Catch Fake, a project that we were working on the whole semester. So, what is Catch Fake?
Well, let's address that. Catch Fake is our product that we made, and our mission is to create an open source tool that can reliably distinguish the difference between real and deepfake audios. Now, you might ask, what is a deepfake? I mean, you probably already heard it many times tonight, but deepfake
are synthetic videos and audios created to imitate real or fake people generated using artificial intelligence. Now today we're going to go over some problems, statistics, and models that we use, the tech stack, and our own demonstration, and the feature tools that we have for our products. Now, raise your hand if you've been a victim to a scam for, like a voice call. My bad, I was saying remembers. If you've been a scam, I'm sorry, I'm just remembers, my bad. But even the biggest companies today have lost millions of dollars due to these deepfake audios scamming them just simply because they think it's somebody else. So deepfake audios can be used to access secure systems leading to scams and illegally accessing information that they really shouldn't. It can also lead to misinformation that's being spread by your favorite celebrities or political leaders in the world. Now, 66% of cybersecurity professionals experienced deepfake attacks in 2022, and 38% of companies have experienced up to over $400,000 worth of loss. And almost 90% of computer-generated content on the internet is going to be computer-generated in just about 2 years.
So what did we do to solve this problem?
So we trained using various different models to become better at detecting deepfake audio. The first model that we use is ResNet-18, which is a convolutional neural network that analyzes data in the form of spectrograms, which are audio converted to image format to feed to the model. The second model that we used was Whisper, which is OpenAI's automatic speech recognition tool to perform feature extraction on spectrograms before feeding them to the neural network. The third model that we tried was ResNet-3, which uses waveforms instead of spectrograms as image representations to feed to the model. And the fourth model that we experimented with was ResNet-18, which used a modified dataset from our original one to include background noise to better generalize to real-world audio. So the datasets that we used were ASU-SPOOF, which is a well-known dataset used for competition in which researchers compete to create the best deepfake detection model, and In the Wild, which is a dataset with real-world celebrities dataset audio samples with 20 hours of real samples and 17 hours of fake audio. So ResNet-18 is a neural network, which is specifically a convolutional neural network which uses image features to perform classification. So for this model, we converted audio to spectrograms, specifically Bell spectrograms, which are used to be more in tune with human perception of audio. And this model, we were able to achieve over 99% accuracy with the data that we tested, which was in the Wild dataset. The next model that we tried to further generalize our model to more types of data was Whisper, which is OpenAI's automatic speech recognition tool. And we used Whisper's feature extraction to be able to extract features from spectrograms and perform classification. And this model was able to improve performance on playback audio, which was played back on your phone onto your computer when you're going to test whether audio is deepfake or not. The third model that we tried, which saw a higher increase in performance, was ResNet-3, which was originally trained on speaker recognition, so classifying which speakers are speaking in audio, which we modified to categorize into two categories instead, fake versus real. And the last model that we tried was ResNet-18, our original model, which used noise by adding background noise from training data to generalize to more real-world audio, which we also hope to improve generalization on to be used in the real world. So in a nutshell, to summarize our tech stack, we used React to develop the UI of our website. We used Flask to create the APIs to receive results from our model. We used Python and libraries such as PyTorch to develop the neural networks and machine learning tools that we use. And we deployed our website on AWS EC2 to make it accessible to any user who wants to detect deepfake audio.
Okay, so now we're moving on to the product demo, and it's enough of the nerd stuff and all the important models that everybody is using here in this room practically. So now we're gonna listen to audios and see, does our model work actually? Okay, so the first audio is from Donald Trump. Let's hope that if you can classify it as real or fake.
Exact science based on theories, not on theory.
So how many of you think that is real or not? I know that we, okay, just replay that.
They're well known fictitious and deceitful work. Exact science based on theories, not on theory.
So how many of you think it's real or fake? Any ideas like it's real or fake? It's fake. It's fake? Okay, so let's test it.
Let's try. Okay, so this audio.
So as you see that we detected a spoof. And now we're going to test the second audio. So as we test the second audio, we see that the result is modified. That means the audio is real. And we are not playing the audio right now because of microphone issues, and we will be really happy if you come to our Excel and we can show you our website, the Lifetime website, and you can test it. But here comes a question, like, you're gonna say that you guys have pre-trained the model, come on, even I can like show you like fake stuff. Let's test this in the real world, like what if we generate our audio right now and check?
Hi, Jack. This is Chris from the payroll department. I'm just calling to confirm some banking information we have on file for you. We want to ensure accuracy for your direct deposit.
Now, if we put this file, it would
have to move on.
Yeah, sure.
But everyone, let's give it up for.
All right. Next we have Matt's group. That's called Libretto.
Yeah, it should be. Okay. So, would you say the way they got it at the end where the microphone was playing from the laptop was that not good enough?
If you can fix it, please. Like, what was the problem?
So the thing is, the audio is being routed here, so people on YouTube can hear it, but it's not connected to these speakers.
Can we give priority to us rather than YouTube?
Yeah, we could by just plugging it in and foregoing the stream, if that's.
We're gonna record a video anyways after, so let's get our audio.
Okay, then yeah, just plug it in manually.
Plug it in. We're gonna have audio.
Wait, HDMI?
Yeah.
Yeah, we're going old school.
And then can we test it out real quick?
Yeah.
Okay, so once we get in the presentation, just like play a couple seconds of audio.
Where's the talk?
Who's got a YouTube? Is it gonna put my entire YouTube recommendation up there? I'm not doing it.
Just play the.
This is you, right?
Do the thing. A little bit of audio from our.
Is this your desktop back here?
Oh, hold on. Check it out. Boom.
And yeah, just
okay. Nobody look. Spoiler. Okay.
Can you hear it? Should it be playing something?
Okay, yeah, it works.
Okay, cool.
All right. Believe in you guys.
Thank you. All right, everybody. Is this working? Doesn't sound like it's working. Okay, I'll just speak really loud then. Okay, so welcome. We are Libretto. We are a brand new lyrical transcription service, and we're excited to show you what we got. So, our mentor is the lovely Matt Duma. My name is Hassan.
My name is Amaya.
My name is Ruben.
My name is Jonathan.
And I'm Mariam.
Hello everyone. So every time you listen to music, some of us want to, listen to the music and see the transcription as well. So on Spotify, you might want to see the lyrics, but sometimes it hits you up with a sorry, we don't have a transcription right now, and it's annoying, isn't it? Indeed. Or you'd go to YouTube, and then you will turn on the closed captions, and the lyrics you will get from there will be somewhat off, or maybe a lot off from the actual stuff they are trying to say. And to make the matters worse, when you take into the account that there are thousands of languages, dialects, and slangs, it makes it even more difficult for a new language learner to understand the cultural context. And this is where Libretto comes in as an accurate literal transcription service.
And moving on to our applications, we wanted to target our intended use to basically anyone who's trying to learn new cultures and basically trying to learn a new language. And we felt this would be very useful because through music you can learn a lot of new slangs, new idioms, and basically just new jargon. And whereas like opposed to a textbook, you can't really learn as much. And we also felt like this would be very useful to people who are hard of hearing and basically help them to understand the accuracy of the word. And lastly, we also thought that from a business standpoint, this would be very effective if we use it in the music industry, and we'd help out producers trying to transcribe new unreleased music and just basically music that hasn't been transcribed yet.
So for the overall view of our system, first the user can put in a YouTube link or an audio file like MP3. Then it goes through a model that separates the vocals from the instruments. And then next, it goes through a fine-tuned automatic speech recognition model that actually converts that vocal into transcribed text that the user can see at the end.
So the vocal isolation subsystem is the first subsystem out of the two subsystems that are there. It works behind the scenes, and so basically it just separates the audio from the rest of the music, including instruments and all the background music. And the vocals will be sent into the ASR subsystem as input. And we rigorously tested multiple softwares, and we determined that Demux was the best software because of its low signal to noise ratio as well as the sharper audio that it provides.
And moving into our automatic speech recognition subsystem, we decided to go with Hugging Face's Whisper model. And the reason we went with this one was because it had faster results and it really set us up for fine-tuning purposes with Laura. And I'll let Santik talk more about that.
Yeah, so Whisper is great, but how do we adapt this model to our particular use case of wanting to apply it to musical transcription? So for this, we applied LoRa, which is a new technique known as low rank adaptation that allows us to fine-tune our model with a minimal amount of training data. So what do we train this on? We used a lot of hours of studio recorded and royalty-free music to give the model a sense of the spoken versus sung word, analyzing that, as well as Aaron mentioned earlier, different dialects, slangs, and jargons that could come across in music. So now to kick it to an actual demo, what does Libretto look like? Well, we're excited to show you.
So first, you can see that you can put a file or a link. Here we chose a file. I'm going to play a song a little bit for you.
Sometimes I question whether this shit matters. Put the substance into something.
Next, we're going to click submit. And when we click submit, it'll actually put through that model that affects the vocals, where we can hear a clear vocal.
Sometimes I question whether this shit matters. Put the substance into something in the world. So you think this the gratification.
And you might have catched that the artist said gratification with like a pause in the middle, but you can see in the transcribed lyrics that actually was able to read that word.
So with Libretto, we hope to help people expand their cultural horizons and learn more about other cultures and other languages. And in addition to that, we hope that it'll help people who are maybe hard of hearing to be able to learn their favorite song and know the lyrics to them.
Now, how do we grow this impact? How do we grow Libretto? Well, the first step for us is adding support for more languages, including ASL, as well as adding a defining tool so that we have these lyrics available. Now, to implement this cultural context, this learning of languages and everything, allowing the user to select certain words or phrases and have that defined with another integrated AI model. So finally, the last one we thought about is expanding this to an instrumental analysis so we can gather what qualities the song has, such as the happiness, how happy it sounds, how sad it sounds, to give more context to the song. and enable all our users to just learn with that much more depth. So that's Libretto. Thank you all so much. And if you want to see how it works with your favorite song right now, make sure to catch us at the symposium. Thank you very much, everybody.
All right, thank you, Libretto. Next up, we have a sentence group called Price Partner.
Yeah, just click present. You don't have audio, right? Is it just slides or you have also a different demo?
Oh, we have a demo.
Okay,
We
then
have
just
switch tabs.
Yeah, just full share screen.
Thank you.
Hello everyone, my name is Eza.
I'm Nihant.
And I'm Rajvi. And we are Price Partner, where tomorrow's prices is today's strategy. So we wanted to create a model that would sort of alleviate the current problems we see in the retail industry today. One of the first ones being inventory management. Sometimes we go to a store and we see that a certain product is out of stock or that they have too much in stock and nobody's buying them. The second problem that we see is demand uncertainty. This is where retailers don't know when a certain product will do well, and this can lead to a loss in sales or just excess costs. And then our third problem that we see is within the supply chain itself. A lack in coordination can lead to high transportation costs, high energy usage, and just unsustainable practices in general. So what is the solution? Well, Price Partner is the solution. We wanted to create a model that accurately forecasts product demand. And the great thing about Price Partner is that we include seasonal variation and other external factors that may affect pricing. And we also offer product level forecasting.
So for our solution, we made a demo where retailers are able to choose a specific product type, such as laptops, iPhones, monitors, cables, etc. And it shows the sales and forecast of each individual product throughout the year. And while this demo takes some time to load, we're just going to step back a bit and kind of talk about how we got here. So first, when we were given the data set, we kind of just saw what variables we were given and what questions we wanted to pursue. We then did some data cleaning and manipulation using pandas, where we got rid of any duplicates, NA values, and made a column for total sales for each of the product types. From there, we did some EDA, making bar graphs, scatter plots, box plots to analyze any of the trends we've had. Using that, we made a SciMax model and then our demo, which was previously shown. And now we're going to look at some of the EDA.
So these are just some of the EDA graphs that we made to better visualize our data. The line chart at the top shows us the total sales over the course of 12 months. The scatter plot at the bottom shows us the number of purchases of each product type over 12 months, and then the bar graph is just a total number of orders of each product type.
So what is StarMax? StarMax is an intuitive time series forecasting tool. And when we were going into this, we really wanted to have a model that would not only be looking at previous sales data, but would also be able to use and take into account other external factors as well. And that's why StarMax was perfect for us. To predict product sales, StarMax, for our model at least, took in product sales from the past year, and we also took in 3 other external factors. The first one was if that day was a holiday or not. The second one would be if a certain product was on promotion, for example, if it had a discount. And our third factor was oil prices, so that we could observe general market data to see how it would relate to product sales. If you take a look at the graph, you can see the sales plotted in the blue for the entire year from day 0 to day 360. And the orange line is our model forecasting and predicting the product price throughout the entire year. Now, we want to take a closer look at how the model performs for different time periods. So as you can see here, we have various graphs from 60 days, 90 days, all the way up to 270 days. Our model did really well
across different time periods, and that's exactly why we wanted to take a look at it. As for the performance of the model, our model works extremely well for individual product categories. Like Roji mentioned, this can be anything like laptops, headphones, batteries, and more. The graph that's currently up there is for headphones, and as you can see, it's moving up for the spikes, the dips, as well as generally predicting the middle layer as well. Moving forward, one thing that we do want to do is add in availability for the model to predict overall sales data. So this would be all the products combined, so that if you were a business owner and you wanted to know how much money or how much revenue you would earn each day, our model would be able to do that for you. All you would have to put in is previous sales data and what products you're selling for that day. We also want to have personalized product recommendations, so that if you are a Walmart in Texas versus your Walmart in New Hampshire, there would be a bit of a difference on how the product price and the product sales would vary across both those places. Now we can go back to the demo real quick, and Ruji will talk about that.
So in the output, it basically just shows the laptop sales and forecast throughout each year. Right now, you can basically just see the accuracy of our model, but in the future, we would like for it to predict the next 5 to 6 months of sales for the retailers to be able to use.
And here's an appendix of some of the more EDA that we did that wasn't included in the previous slide. We did a lot of this EDA just to understand how we should approach the model and what was actually useful. And thank you.
All right, thank you, Price Partner. Next up, we're going down to our final 3 groups. So next up, we have Rajo's group called Pandai.
Click this down for me. I don't have any audio or anything. You do have audio? Okay. Yeah. I'll just do everything just to be safe.
Entire screen?
Yeah. Yeah, okay, this is working. So.
Man, I'm all out of money. I know I have to invest, but I don't know what to do. I wish there was somewhere I could go where I could figure out what I'm supposed to do to invest.
Excuse me, are you a broke college student? I mean, a beginner investor that knows nothing about investing?
Yes, I am.
Well, have you heard about Pandai, the app that helps beginner investors start their investment journey?
Yes, I have.
Hi, my name is Laura.
I'm Odom.
I'm Kaya.
I'm Sammy.
And I'm Aman. And today we're introducing Pandai. Our aim is to make investing change forever. The current state of financial advice is terrible. For a beginner, financial advice is both expensive and complex, making it inaccessible for many. Our aim is to make financial investments easy and smooth for everyone. This is needed as billions of dollars go uninvested in the stock market each year in the US. Our project uses intuitive tools that allow even a beginner to make good financial decisions based on sound information. Some of these include sentiment analysis, which summarizes headlines telling you what people think, and financial portfolio management, which uses historical data to forecast the performance of stocks. We use artificial intelligence and machine learning to give high-quality, affordable financial advice from diverse data sources. Now to Odom to talk about where we get those data sources from.
All right, so we used a mixture of APIs such as Yahoo Finance, Alpha Advantage, to gather a collection of data points where we had over 400,000 data points that have been pre-processed and featured engineered to a T. Our data was so huge we couldn't even pass it through our Discord or our GitHub. So now I'll pass it on to Sammy, where he'll be showing our homepage.
Thank you very much, Odom. So here on our homepage, the user has access to all of our 5 features, each with a drop-down menu that explains in brief detail what each one does. So to get started, press the button to start your financial journey.
Before we get started, I want everybody to listen to the music and take a deep breath with me. Ready? Inhale and exhale. So why would we do that, you may ask? At Pandai, we encourage our users to have a calm and free mind before making big investment decisions, as our emotions can often cloud our judgment. So with that, I'm going to hand it over to Odom to start our investment journey.
All right, so here we have a risk aversion questionnaire where we'll be answering a set of questions that reflect your personal risk tolerance. What sets Pandai apart is that we'll be using those answers along with our LSTMs and Black Litterment optimization approach to analyze the market, thus maximizing your investment portfolio. What this creates a pie chart that shows your allocation with your funds into different market sectors. This tailored approach aims to empower your financial journey. So now I'll pass it on to Kaya with our stock search feature.
Thank you, Odom. So our stock search feature allows every user to look up specific data regarding their desired stock. So let's say they used a portfolio and they saw their biggest allocation was the information technology sector. So let's look up the Apple stock. So all you have to do is put the ticker into the search bar, press search, and we generate 100 of the most recent headlines of articles relating to that specific stock. And on the right here, you can see the sentiment analysis scores that tells the user if the stock is being talked about in a positive or a negative light. And now below this data table, we see the summary feature, which combines all of 100 of these headlines along with the open source Mixtral LLM model to generate a summary that concisely forecasts the stock's performance. And then below that, we have the average hourly and daily sentiment analysis scores that just notifies the user how the stock has been doing recently. And now if you're not one for bar graphs or summaries, I'm going to give it to Laura to talk about our common stock feature.
Thank you, Kaya. So similarly to Kaya, we're going to be entering our Apple ticker, and then after that, we're going to be hitting the button search. And while our data is being processed, we're going to be analyzing our latest new headlines for our sentiment analysis. Using this feature is transforming complex data models into easier to understand comic stories for each person and ticker. Our approach is easily accessible and easy to read and understand by our visuals. And with that, I want to hand it over to Sammy to talk about our calendar feature.
Thank you very much, Laura. So with our calendar feature, the user can input whatever stock ticker they would like, and it'll show up in the calendar to allow them to know when the call date is and whether or not the market is open or closed by the indicator. And then finally, we have our virtual assistant, Poe, powered by Hugging Face and Transformers to help ask any questions while navigating the website.
Wow, I feel so much more informed. Got my money right here and I'm ready to invest.
Thank you guys all for listening, and we are
Pandai.
All right, thank you, Pandai. Next up, we have Daniel and Subways Group, and their project is called Animotion.
Does it work? It does work. I tested it right before.
Hello? Yeah, I handed it over, but no one wanted to see it.
Yeah, I should present. There we go. You're good.
Okay, hi, we are Animotion, and our project focuses on tracking animals and their movement when given a video. I'm Kunju.
I'm Justin.
And I'm Sujin. And let me introduce our mentor, Daniel and Subri. And so the reason that we are building a project that's centered around animal detection is due to a recent spike in extinction.
And so currently, approximately 10,000 species of animals go extinct every year. And so there's clearly a need for an intervention, and we believe that AI could be a step in the right direction. We believe that our project could help reduce such rates of extinction or endangerment by first identifying what animals might be at risk of going extinct or endangered, and then later helping us find ways to prevent this by monitoring their movement.
So our solution was an animal detection model. And first, in order to make this model, we had to collect data and prepare it. And so in order to do that, we utilized a Kaggle data set, which had 60 classes of animals in there, which we then imported into RoboFlow. From there, we were able to annotate and put bounding boxes over each image. After we annotated all the images, we exported it, where we then went on to detecting and training. For our training and detecting, we used YOLO V7, and we used YOLO V7 for our pre-trained model for its fast real-time detection with its you only look once object detection algorithm. With our RoboFlow dataset and YOLO V7, we were able to do transfer learning, where we use the base weights of YOLO V7 with our dataset to specifically detect the animal classes within our data when we make our weights. For our training weights, we use at 200 epochs, which we figure out was the best sweet spot for it. And after we did the training and we tested it a few times on a few different detections, we moved on to our front end. And so for our front end, we created a basic radio app where you are able to input a YouTube URL. The output is the detected videos with animals in it. Here are a few demos. Not for the penguin. This one is a bit more of a complex one. It's where we have hyenas and lions fighting. You can see it's not always 100% accurate. It'll like call the lion a pig occasionally, but it does its best.
So initially, our team at Emotion had a plan to develop an AI model to help and protect human beings. However, throughout our weekly meeting during last 12 weeks, we have noticed that it has much more potential. Just rather than just helping human beings, it could also help endangered animals. So, related to this, we have decided 3 major future implementation. First, we'd like to train our model with larger number of data sets to increase the accuracy and also the number of the animals that we can detect through our model. So second, we also like to enhance the user experience using our model by adding additional pipeline to show the text box of our hosting site. Lastly, we like to differentiate our model to increase the scalability of our model by training the model with the data set with region-specific animals. Thank you so much.
Hello? Okay, and then for our last group of the night, it's gonna be sign language detector. So, round of applause for that.
Thank you, Animotion. Next up, we have our last group. The sign language is, did you already say it?
Yeah.
Okay. What was your guys' actual?
Sign away.
Sign what?
Sign away.
Sign away. Okay, so the group name is called Sign Away. Everyone, let's give it up for them.
Scoot over here. Yeah, let's see the slides.
Okay, can you all hear me? Yes. Hello, everybody. As Peter Drucker once mentioned, the most important thing in communication is what you don't hear. And we communicate with our body in a lot of ways. We use our body language to communicate. We use our facial expressions. We use our hands. American Sign Language is one such language primarily used by those who are deaf and have a hard time hearing to communicate without the use of verbal words. Today, we're going to show you how we can use AI to improve the lives of ASL signers. And before we do that, we have to first understand what ASL is. So we will show you a few basic signs, and I want all of you to do it with me so we get the hang of ASL. So this is how we do hello. It's very basic. We just move our hand to our side. You can use either hand that you like. So that's how we do hello. The next one is slightly more complicated. We have to use both hands. You bring both your palms, you rub your palms, and then that's nice. To meet is you extend your index, and then you is you point the indexes together. So it's nice to meet you. The next one is I love you. You could probably do this on Valentine's or be secretive when your crush is around. This is very easy, simple. And the last one is thank you. You can do it with either one hand or both hands. Just go out like that.
So, show of hands, how many of you knew these signs before today? See, that's the problem that most ASL signers face, is that most people don't know ASL, which can lead to communication barriers, and that leads to a lot of issues for them in daily life. For example, social interactions, how are you supposed to make friends and interact with others when they can't understand you? Or employment barriers, it can be inconvenient for jobs to accommodate ASL signers, and that can lead to issues for them in employment, and it can lead to issues in various other facets of everyday life.
So as just discussed, we noticed that there is essentially a barrier going on between ASL signers and English speakers. So how are we going to address this? We chose to create an AI model that uses ASL sign detection in real time. In doing so, we're going to be able to essentially break this barrier. And what that'll do is that'll increase the number of quote-unquote interpreters that we have. That's what our model is doing. And that'll imply and create a decrease in the discrimination that ASL signers face in the workplace. And it'll also decrease the isolation that they feel. To do this, we basically use ML to create our model and actively recognize these actions and signs. And we only have a couple right now, but we plan to implement a lot more in the future. Let me pass it on to Zaim, who's going to be talking about specifically how we implemented our model.
Yeah, so how will we go about, implementing real-time, sign language detection? So the first part is having the input data, which would be a camera, but we need to have it in a way that we can do operations on it. So we utilize OpenCV, which returns data in a matrix form. And then what we do is we have another library, MediaPipe, which allows us to interpret it, various components of that visual data. For example, hand data, pose data, and facial data. And what we do is we feed that into a model from TensorFlow called LSTM, which stands for long short-term memory. And what that does, it lets you interpret sequential data a lot better because we're dealing with words here. It's not just a single sign. So the sequence of those frames are very important. And then in terms of the data, we did a couple, videos of our own, and we trained the model with that. And I'll pass it on to Harsha for a demo. So this demo uses my laptop's camera. Hopefully
Oh, we gotta play.
Okay. As we can see here, this is the media pipe drawing the landmarks on me. So that's my face data that's being captured and my hand data. And you can see to the top left of the screen, there are the predictions that the model will do. So let's try hello. So this is, it should hopefully turn green. It doesn't. Okay, let's try thank you. I mean, it's on thank you right now. Let's try maybe a little closer. Okay. For some reason, it doesn't work today. Maybe, let me try without the mic. You want to hold the mic?
There we go.
There we
There we go.
This is.
Yeah, there it is.
Okay. Okay. And I think this. Yeah, I think the mic was an issue. Yeah, this is a demo. Okay. And this is.
So there's a very clear impact that this technology could have, because by enabling real-time ASL translation, we're able to bridge the communication gap between those who understand ASL and those who don't. And in doing so, we can increase the opportunities for those who are deaf or hard of hearing, because businesses could easily incorporate this technology into their workflow, and as a result, that greatly expands the employment opportunities for those who are deaf. Thank you very much for listening.
All right, that was the last presentation. Everyone can finally stand up, stretch out after sitting down for that was over 2 hours. I'm gonna go set up my computer and we'll get the lights back on. But next up is gonna be the symposium style question answering. So just hold on tight for that while I set up my computer.
I imagine
Now my entire face all black.